I've got to set up this loop detector and loop detector harness along with a test loop for a little speaking engagement that I've got. It's actually going to be for another project that I wanted to do, which had to do with these DIY test loops. But because I need to get it done, I'm going to go ahead and actually record this part of it now and then just put it in the middle of the other video that I'm going to do. So this is setting up a loop detector so you can use it on your bench. So I knew the coloring for the power, the loop, and the relay, and the only one I didn't know the color for was the normally open and common for relay 2. I'm going to take the open of relay 2 and the common, which is orange and red, and twist those together. The three colors I have left are purple, pink, and green. So purple is the normally closed relay 2, and pink is the normally closed presence, and green is ground. I wonder if that green is a ground for the whole unit. If that's the case, I never knew that. I never hooked green up. The only ones that I would hook up are power, relay output, and then the loop. But if it's got a ground on it, that'd be pretty interesting to know. Could possibly save some of the loop detectors from getting fried. Since I'm not 100% sure whether this pink and purple, or they call it a violet, is it actual another input or not, it's not going to hurt to just go ahead and twist it together as well too. I'm spinning it up a little bit more than it actually needs to be, and then I'm going to back it off a little bit so it doesn't twist all together. And from that big mess before to this, I've got this terminal block that's cracked in half, so I'm going to cut this other side of it right here and then probably hot glue it down so it stays in place. But what I want to do with it is I want to be able to plug the output of the loop detector into this and then jumper over to the other side so I can have multiple outputs. And you would think just a couple would be enough. I may only do this one because you can actually connect more than just a couple of those spade connectors on each side. So that probably would give me enough if I just cut those 4 of them out. But I'll cut it in half since it's already, or I'll cut it right here since it's already broke, and then I'll probably just hot glue these pieces on there so the little protection ring stays on there. I don't know, we'll see how it goes, but I gotta cut it anyway. So I'm going to put the power with one of these connectors right here. I haven't used one of these before yesterday or the day before, and I just connected it. I didn't actually use it to see how good the connection was, but it's a pretty interesting little connector. You feed the wire right through there, and then you don't have to strip the wire. You put each one down in there, and then pressure, you put that together, and then push it in just like that, and it locks in there, and you can't get it out. So I'm going to go ahead and hook the black and white up to that. I'll get them the same length first, and then I'll straighten them out just a little bit and feed it through here first. And there's no polarity, so you just push them down, one on each side. Doesn't feel like it's going down deep enough. So you can see down in there where it needs to go. If I can get it in there. And it looks like it goes pretty much all the way to the bottom. Yeah, it does. So just push those in there. Almost an inch, it looks like. And there's a little pressure about halfway down. And then it looks just like that. And then you push those in, and that actually pierces the insulation. So it's an insulation displacement connector. This is the interesting thing about it. Once you push this thing in here, a little trick that I had to figure out the other day in order to get it all the way in there was to get you an outlet that's obviously not energized, and then push it down, and then that pops it in there. So probably got out of focus there for a second, but you just push it, then put force on it, put a lot of force on it, and it pops it down that last 1/4 inch and locks it in there, and then you can't pull that back out. Once that connection is made, it's supposed to be permanent. So I guess what I'll do is I'll plug it in and see if we get 120 volts, and then I'll plug it into the loop detector. Alright, so the first thing to do is plug it in. I want to plug it in before I put my loop detector on there, but I could easily just plug the loop detector in, and if it has power, then we're good to go. Not sure I can see where they're numbered, so I'll just try these two. It looks like they're the closest ones. Let's see, 1 and 2. It looks right. I'm not getting any voltage. Okay, it looks like the meter's working just fine. It jumps up there like it wants to tell you it's about to get voltage, but then it doesn't. So what probably that means is one of those connectors aren't connected. So here's what we'll do. We'll go ahead and put the meter on continuity. So we got good continuity there, and no continuity there. Crap. So I don't know if those connectors are any good or not. We'll see. I'll check it this time before I actually put it on there. When I got more time, I'll probably cut that apart and check to see where the fault is. You can almost see down in there, but it's hard to tell what's in there and what's not. Anyways. This time, before I actually clamp it down, I'll make sure I got good continuity. You actually can see the wire in there, and that could be what it is that I didn't push it down far enough. But it looks like that's the appropriate gauge. Looks like it fits in there okay. And it's a little bit easier to see on this black one over here. I'll pull it in and out and show you what's going to see. Right there, so I guess you got to make sure you've got it pushed down all the way. And then hope that pierces it. So now we'll check. Alright, so we got good continuity there. Good continuity there. Oh, and you already see where I screwed up. Forgot to put the wire in there first. Let's try that again. And you can see how it pierced it. It pierces it twice. So that seems like that would be a pretty good connection. I'll cut it a little bit flatter this time. Push that thing down as far as I can. Hold it down there, and then you can see it down there. It's all the way down. I'll pull it back out just a little bit so you can see how it's all the way down there. That black part that's going in and out. Push that thing. Now I'll get these tight. Now I'll double check my continuity. Alright, my leads are plugged up good. Got good continuity there. Good continuity there. And once it's in there, it's not supposed to come out. That's what the final connection looks like. Got it plugged in. Okay, we got good voltage. Plug in our loop detector. And it's flashing at us. And I know what flashing means, but I'll just quickly read the manual. I think if I was going to do this again, I'd probably buy this type of harness right here. I don't know if that has a specific name. And it looks like ground. See, I didn't know this. Ground must be connected to earth ground for surge protection to be effective. I didn't know that that was a ground. That's good to know. And let's see. I'm not going to look at the details just right now, but green indicator is not lit, no input voltage. We know we got input voltage. Green indicator flashes, loop wire shorted or disconnected. All right, we can solve that. Got my test loop here. I'm going to go ahead and cut this off. I want to redo this connection anyway. It shows that the loop's brown and gray. So let's go ahead and cut this one back. And because I'm in a hurry, I'm going to use my cordless drill. Polarity is not an issue. Yeah, I'm going to have to get another harness for this, especially if I want to use this as a demonstration tool. So if our loop's any good, we should see that light stop flashing here pretty soon. So we went from flashing every once in a while, or at about a 50% duty cycle, and now we're given 2 quick flashes. Well, it still looks like it's flashing about the same. So that's not uncommon for it to stay in detect mode if you hook up the loop after it's not detecting it. So what you would do in this case, and especially because we're just using one loop, we may have to change the frequency if we had it in an actual scenario of 3 different loops connected next to it. So what we're going to do is we're just going to reset it and see if this detect light goes away. It's going to tune the loop to the detector, and it looked like it did that. So let's see if we can get it to detect. Okay, so we changed the inductance of the loop and it detected. And it looks like the loop detector is not in a latch mode, it's just in a momentary mode. I'm going to see if I can hear the relay click after I take this back. Okay, no, it's actually latched. So maybe number 2 is not latch, maybe it's momentary, and that's the actual relay that I'm clicking. Looks like it's working. I was going to use a small car, so that's kind of interesting. Let's wonder if it's because I'm moving that around. Oh, I see what's going on. You see what's happening? The loop detector is causing itself to trigger because it's changing the inductance of the actual loop, causing it to detect. But I wasn't smart enough to see that at first. Okay, so now we shouldn't get anything weird, it staying on or anything like that. All right, I want to see if I can get a little toy car to work. No, there's just not enough. Oh, it looks like it's actually all plastic. For some reason I was thinking it was metal, but that thing's all plastic. So I'll either have to find a little toy car or just use this box for my demonstration. All right, found a car with enough metal. Now I'm just gonna cut this thing in half real quick and show you how I'm gonna use this thing. I bought this Dremel A550. I wanted the quick, they call it an easy lock. I was gonna call it a quick lock. I want the easy lock mechanism out of it, and this was the cheapest thing that they had that. I've got plenty of disc. I just wanted the little easy lock mechanism, and it happened to come with this little shield right here. So I'm gonna cut it apart and put it on my cordless one and see how it works. Oh shit. It came with a sander too. I can use that. I don't really use these wire brushes all that much. It looks kind of cool. Let's see if it works. Most of the time these shields just get in the way. And it looks like it's already going to get in the way of me tightening this down. Well, actually it moves pretty easy. So actually that's fine with me. If you've never used one of these easy lock cutting wheels before, and you use a Dremel quite a bit. I'm not sure if they make any wood ones, but I use these metal ones for plastic and wood all the time, and they seem to do okay. And they just pop in there just like that. Makes it a lot easier than it used to be. But how do you like that? Well, I guess it's going to cover me from getting any stuff directly back like that, but I guess if you put it all the way back, it just barely covers it. Well, something's better than nothing. So I'm going to go ahead and cut this piece. Yeah, if you do cut plastic like that, it'd probably be best to cut it outside. That stuff smells pretty bad. Trim all this stuff off. It's a little loose right there, but there's enough pressure on the end of this to hold that thing in there. I'm going to take the output of the relay, this blue and yellow right here, and I'm going to go ahead and make connections on it and put it on the other side of this terminal block. I'll do everything coming from the loop detector harness on this side. I was thinking I could get away with just this many inputs for now. I'm going to have to use this one right here. I forgot I need to be able to run this output in parallel to multiple devices. So I'll wire it just like I had it before. I'll put everything from the loop on this side, and then I'll put my incoming devices over on this side. Now on this, because it's from the relay, polarity could be an issue with certain devices, but typically it's not. All you're doing is breaking one leg of a circuit. Alright, so it recognizes the loop. Now let's hook up my magic device. I didn't have any blue and yellow wire. I'm using blue and red for right now, and it's going to be easy to get that confused with the violet and pink. So I'll just use this temporarily for right now, since I've got to get this done in the next couple of days. But ideally I'd like to keep the colors the same, and since this is coming from the relay, it's blue and yellow. So this device right here is a little sampling device. So you can press a button and it'll record whatever sound input comes in from the mic. I've seen people actually modify this where it takes line level signals too, so you can get a little bit better quality. I've taken the push button and soldered a wire on the top and soldered a wire on the bottom. It looks, I did this a long time ago, but it looks like the connection's still solid, so I'm going to go ahead and leave that. I may redo it in the future, but I don't think I have a very small tip, nor did I when I did it, and the solder joints aren't perfect, but they're electrically sound. I'll go ahead and solder these leads directly to this two legs off of the sampler, and then we'll test it out. It's going to be a little bit of a pain in the butt to do. Soldered the clip to the leads. I'll have to mount this on some kind of board or something like that so it travels well. It's got the same setup here. We've got the loop connected to the input of the loop detector, out of the loop detector, going into this little terminal block here. Out of that, going directly, it's soldered onto the inputs of this little sampling unit. Because I didn't hear something right now, it's probably not working. So let me try that one more time. So let's record something on here. I'm Rick James, bitch. Alright, so we've got an issue. We've got no current draw. I got this hooked up right. And I may just have fried something. Alright, let's not plug it into the power supply. I got a feeling that thing's done for, so let's see if we get anything. Check it out. I'm Rick James. Blue and yellow. 1, 2, 1, 2. Check it out. 1, 2. Oh, let's take a look at what I blew up. Not 100% sure, but I think that that's a transistor right there. It's labeled as U2, I believe. So I'll have to see what that is. I'll see if I can look this part number up and see if I have that transistor. I doubt I do. I don't carry very many parts. And even if I did, I probably fried something else as well too. So I'm going to briefly look up to see if I can find that. If not, looks like I'm going to have to go buy a new sampling module.
Don't forget to like and subscribe.
The one input hooked up from the coil, and then I've got the output, which is this wire right here, hooked up to the play button on this little sampler. And what I wanted to do was take a look at the voltage over time and how it reacts when this coil has a piece